All right. Hello, hello. Long time no see. I hope you're having a good day today. I want to do a quick run through of question 7 from the classwork. So, a local radio station plays 40 rock and roll songs during each 4-hour show. Program director at the station needs to know the total amount of airtime for the 40 songs so that the time can also be programmed during the show for news and advertisements. The distribution of the lengths of rock and roll songs in minutes is roughly symmetric, with a mean length of 3.9 minutes and a standard deviation of 1.1 minutes. So I'm also going to underline that it's roughly symmetric. This is all important information. 1, or A, describe the sampling distribution of the sample mean song lengths for random samples of 40 rock and roll songs. Okay. When it says describe the sampling distribution of whatever it is, we're looking for, is it normal? Is it normal? And how do we know? So that then leads to conditions. And once we know, usually that it is normal, it can be described by a normal distribution, then we want to establish the mean and standard deviation. So since this is about mean length, specifically mean length, and it's not a proportion, we need to think about our conditions for means. So make sure we've got all the pieces and parts here. So for means, we want to think about the original population. It says that the distribution is roughly symmetric and probably unimodal. So we can say that this is pretty normal, but let's check everything else just to be sure. So then the next thing we'll check is it small enough? Right? Is our sample size small enough? So N has to be less than 10% of the population. So our N is 40, and it's reasonable to assume that 40 songs is less than 10% of all rock and roll songs. And again, it's tedious, but context, context, context. Okay. Now, is it random? Well, we're gonna say that this 40 songs is representing a random sample of rock and roll songs. So 40 songs represents a random sample of rock and roll songs. I'm just going to say rock songs. You've got it. All right. Last but not least, is it big enough? So for means, big enough just means is n greater than or equal to 30. Well, 40 is greater than or equal to 30, so it's big enough. All right, so we've checked our conditions. So all of that to say that we can use a normal distribution with a mean. And so the mean of the sampling distribution is the same as the mean overall. So a mean of 3.9 minutes. And a standard deviation, since we know that the standard deviation of all the songs is 1.1 minutes, that's the population, we're going to use our sigma, our Greek letter. And the standard deviation of this is going to equal the standard deviation of, for one song, of 1.1 minutes over the square root of our sample size. When we do that, we get 1.1 divided by root 40. That's roughly 0.1739 minutes. I'm not going to round it too aggressively just yet because I want to make sure that at the end, I haven't rounded too soon. Okay. So that's part A. Describe the sampling distribution, normal, of sample mean song lengths for the random samples of 40 rock and roll songs. So here's that. Now, part B, this is where we apply it. If the program manager schedules 80 minutes of news and advertisements, try and make a little more room here. There we go. So if the program manager schedules 80 minutes of news and advertisements for the 4-hour or 240-minute show, only 160 minutes are available for music. Approximately what is the probability that the total amount of time needed to play 40 randomly selected rock and roll songs exceeds the available airtime? And so the available airtime is this 160 minutes. So we could do this in two ways. Personally, I'm going to think about it in terms of the 160 minutes. And when in doubt, draw it out. So here is my normal curve. And if I have 40 songs with an average of 3.9 minutes per song, that would give me a predicted mean of 3.9 times 40, which is 156. I'm predicting, based on my distribution, if I have 40 songs and each is 3.9 minutes, each is perfectly average, that would be 156 minutes. For the standard deviation, I'm going to multiply this by 40 songs. So I'll say 40 songs by 0.1739 minutes of standard deviation per song. And that's going to give me my standard deviation. So that times 40, which is about 6.957 minutes. So this was 156 minutes. Now, you could bring this back to just the per song. You could do the 3.9 and the 0.1739, and then you just divide that 160 by 40 and kind of go backwards. Either way, this is what makes the most sense to me. Now, the question is asking about that 160 minutes. And 160 minutes is going to be to the right of our mean and less than one standard deviation to the right. So I'm going to say 160 minutes is like here, a little bit before that inflection point. And we want to know the probability that the amount of time needed to play 40 randomly selected songs exceeds the available airtime. Exceeds means we're going above. So that's going to be what's right here under that curve. Great. We have a normal curve. We have a mean, a standard deviation, a point of interest. Sounds a lot like normal CDF to me. So we'll say normal CDF. And then we're going to use our point of interest as our lower bound because 160 is the bottom of what we're interested in. So this is our lower bound. It's the point at which we've exceeded the available time. For our upper bound, again, we're going to approximate infinity by just saying 1 times 10 to the 99th. And so this is our upper bound. We just want it to be so ridiculously large that as we go this way, we're getting essentially all of those teeny tiny little fractions probabilities. Realistically, we could probably make this, 10,000 and it would capture most of what we want, but putting it so high basically ensures we're capturing everything. mostly everything. Okay. So then for our mean, we're going to put 156. This is our mean of the sampling distribution. And for our standard deviation, we're going to do 6.957. That's our standard deviation of the sampling distribution. And when we pop all that into normal CDF, we get 160 times 10 to the 99th, 156, and 6.957. We get that there's about a 28% chance that we will exceed the available airtime. And so to answer this in context, there is about a 28.27% chance that the play time for 40 rock songs will exceed the available 160 minutes of airtime. Cool. I hope that was helpful. Have a wonderful rest of your day, and I'll see you on Friday.